so let's talk about how do we deal with naming acids that are derived from binary compounds. Now, these are binary compounds which will contain hydrogens, which was the subject of the short video I posted before this one. So, when it comes to binary hydrogen compounds, when they dissolve in water, they form solutions that have acid properties. Now, acid properties, that's a different topic. I don't want to get into it right now, but basically, you can just assume that this is basically what's going to happen. There are certain properties that are associated with acids, which we will talk about later on. The point here is that these solutions are given acid names which are different from the names of the binary compounds which form these acids, right? Now, therefore these acid names are separate and apart from the ide names that are associated with these compounds. Hydrogen is typically the first element in the binary acid formula. So, let me go to this here. Okay, so basically this is what happens. You have your binary hydrogen compound, all right? And if you take it and dissolve it in water, then the resulting solution is going to be the acid solution, all right? So that's how the acid is formed, by adding your binary hydrogen compound to water, and you get your acid solution, all right? Now, as far as the compound is concerned, the hydrogen compound, the binary hydrogen compound, its name always ends with IDE. We talked about how we name these compounds, right? No prefixes, just hydrogen, the stem of the name of the other element, and then IDE. However, when dissolved in water, the name changes to an acid name, right? In fact, to name binary acids, we identify the stem of the nonmetal name, and then we put hydro in front of that stem, and then we end it with ic acid, right? So those are the rules for naming binary acids. So they're a bit different from naming the binary hydrogen compound, which is used to make the acid. So I'm just going to highlight a few examples so that you understand how we derive the names of the acids from the names of the binary hydrogen compound. So the first one here is hydrogen chloride, HCl, all right? So we all understand how we name this. Hydrogen followed by the stem of the name of the nonmetal element, and then ends with IDE. When this compound is dissolved in water, then the resulting solution is now hydrochloric acid, right? So we start off with hydro, the stem of the name of the nonmetal in combination with the hydrogen, and we end it with ic acid, all right? Here's another example. This is known as hydrogen iodide. The name of the corresponding acid is hydroiodic acid. All right. The name of this compound is hydrogen sulfide. The name of the corresponding acid when it dissolves in water is hydrosulfuric acid. The name of this compound is hydrogen selenide. The name of the acid formed when it dissolves in water is hydroselenic acid. All right. So that's basically how we name binary acids. All right. Now, this chart that you see on the screen is basically all the rules that we have covered so far when it comes to naming binary compounds, be it ionic or molecular. So, as stated here, the names of these compounds usually ends with IDE. Of course, there are some exceptions, especially when naming acids, but just to concentrate on this part of the chart here, if you have a binary compound formed from two nonmetals, right, then we use prefixes to indicate the number of the atoms of each element, all right, and that's basically it. Of course, we name it according to which element is more metallic, that places first, and the next element, we use a stem name of it, followed by IDE. This part of the chart deals with binary ionic compounds. There are two types, one where the metal has one type of cation, or the metal can have more than one type of cation, and then we go through to name the compound based on that, based on those differences. Again, the ending is IDE ending in both cases, right, here and here. And then over here, this is where we're dealing with hydrogen bonded to a nonmetal. If it is not in water, then it's basically hydrogen followed by the stem of the nonmetal name ending with IDE. And then if it's dissolved in water, then the prefix hydro followed by the stem of the nonmetal that is bonded to the hydrogen ending with ic acid, and that's it. So this is basically a summary of what we covered. It takes practice, of course, to master the skill of naming compounds based on their formula or vice versa. And we're going to do some exercises in class which deals with this. Okay, so I'm going to stop here. The next topic we'll be dealing with are oxyacids. So until next time.